So as we move around the unit circle, if you're watching this video, okay, go back and watch the 30-degree video first, because now we're going to talk about the 45-degree angles, which have radian measurements of pi over 4. And we're going to look at the, the coordinates of this point on the unit circle as well. So again, we've shown that over here. We talked about how the 45 degrees, even though it's labeled on this line, the 45 degrees is labeling the rotation from the positive x-axis up. So that's a 45-degree angle, right? From here to here. And if we drop a perpendicular and we embed this right triangle in here, okay, and we know that the radius of the unit circle, which is centered at 0, 0, we know that the radius has a length of 1. To get to this point, though, we move over a certain piece and we move up a certain piece to get to here. All right. So how do we come up with those measurements? Well, in a 45, 45, 90 triangle, okay, as we've talked about in the past with special right triangles, when you have 45, 45, 90, 45, 45, 90, the side lengths are in a special ratio where whatever the two congruent legs are, the hypotenuse is radical 2 times that. So if we're saying that this hypotenuse has a length of 1, we're saying that x radical 2 is equal to 1. And if x radical 2 is equal to 1, and we solved for x, we'd have to divide by radical 2, right? And we'd get x equals 1 over radical 2, which we would then rationalize by multiplying by radical 2 on the top and bottom, and we'd end up with radical 2 over 2. So what we're saying is that the value of x is radical 2 over 2. That's this distance and this distance. Okay, so when we bring that triangle back, this distance is radical 2 over 2. This distance is radical 2 over 2. So the coordinates of this point are radical 2 over 2 and radical 2 over 2. Okay, so when you look at the unit circle, the complete unit circle, and a couple of things to emphasize about the 45-degree angle. First of all, the 45-degree angle, quote unquote, cuts each quadrant in half. So it's the only angle that actually slices right through the middle of the quadrant. And we have 4 of those, right? We have this one here. Forgive my wavy drawing here, okay? So these 4 angles, when we talk about bow ties and butterflies, these are the angles that have 45-degree reference angles, okay? Every reference angle here is 45 degrees. And these are also the only angles that are listed in terms of pi over 4. Okay, if we look at their radian measurements. So they're pi over 4 reference angles as well. Okay, and then their coordinates, again, the absolute value of these coordinates all match, right? They're all radical 2 over 2. It just depends on what quadrant they're in. Because the one thing you have to keep in the back of your mind is that this circle, quote unquote, exists on the coordinate plane. So positive and x measurements, all the positive x values are on the right side, all the negative x values are on the left side. So these points here and here have negative x values, these have positive x values, and the points up here have positive y values because they're above the x-axis and negative x values below. Okay, so you start to hopefully see the symmetry involved in these coordinates and in these degree measurements. When we talk about reference angles, 45 degrees above 0 is 45 degrees. 45 degrees above 180 or before 180 would be 180 minus 45, that's 135. 45 degrees below 180 is 45 degrees beyond 180. We would add 45 to 180 and get 225. And then the same thing here. We're 45 degrees short of making a full rotation when we get to 315. Okay, let me clear this ink. It's getting a little convoluted here. What we're talking about is an angle that goes from here all the way around to here, right? The reference angle is 45 degrees. So we're 45 degrees short of making that complete rotation of 360. So if you take 360 as an example minus 45, you get 315. So this is how we can use the concept of reference angles to identify all of the angles that are on the unit circle. Okay, let's look at the 60-degree angle next.